Mare 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 mare.
Carbonized papyrus from the Vesuvius eruptions were damaged during the early attempts to unravel them, leading to lost insights into potential Roman life and biblical texts.
Context: in 79 CE, Mount Vesuvius erupted in Italy, bearing Pompeii and Herculaneum in ash, fire, and pyroclastic flows.
This is obviously a bad news to the thousands of people who died that day. Due to the eruption, it might have helped preserve thousands of scrolls containing ancient knowledge in hazardous way.
Herculaneum re-emerged in history when workers digging a well in Resina struck the city's ancient theatre. This led to a mad rush to excavate its treasures.
In 1750 CE, architect Carl Jacob Weber discovered Herculaneum's greatest treasure, a library full of thousands of scrolls containing ancient knowledge located in a nearby villa belonging to a Roman statesman, possibly linked to Julius Caesar. And while earlier methods to open scripts involved rosewater, mercury, sulfuric acids, and even hammering them apart, but they mostly caused damage as the scripts were covered in volcanic eruption.
Camillo Padrini sliced the rolls in half, copied any visible text, and then scraped away each layer.
Father Antonio Piaggio devised a machine using rolled beta skin to unroll the scrolls, but it didn't really work.
These scrolls could hold works no modern person has seen, expanding classical knowledge. But since they were buried and damaged by the eruption, end of story, right?
Well, not really. Modern CT scans offer a breakthrough. We can use X-rays to use 3D images of the scrunched up scrolls to make kind of a digital unfolding.
This is how.
The challenge is detecting ink, as both the papyrus and writing material have turned to carbon. At first glance, the CT scans look totally textless, but if we look closely, we can see tiny cracks which are caused by ink residues.
It can be hard to distinguish these from other kinds of cracks and marks due to damage. But in some instances, they can be read through due to infrared scans providing us concrete data. Just what we need to train our machine learning models to translate text from images.
And that, my friends, is where we see a breakthrough. So now we can design AI algorithms to scan images in tiny chunks, compare details to known ink sources, and then spot ink in uncategorized images from scrolls that have been digitally unwrapped.